Algebra lesson 7-6. Now that we've spent a lot of time working with solving systems of equations, we want to look at solving a system of inequalities. And it's very similar, just like when we first introduced graphing equations and the similarity that was involved with graphing linear inequalities. We wanted to graph as if it were an equation, but we had to pay attention to the solid and the dashed line, whether it was an or equal to or not type inequality. We also had to test a point away from the line, and then we had to shade whichever side had the solutions. In this case, when we're solving a system of inequalities, we're still going to have solid or dashed lines, and we're still going to have shading. But the solution to the inequalities is the shading that they have in common. So I'll try to use some techniques that might help us with that. So for beginners, we want to graph. There are 3 different inequalities here. We need to graph each of those particular lines and shading and see what we come up with. Now, the first one, if we pretend, because we're supposed to pretend momentarily that it's an equation, x equals 4 is going to be a vertical line. It also is going to be dashed because it does not have the or equal to. So this is some information. We should have a dashed vertical line at 4. So I will pick a vertical line, 1, 2, 3, 4, and I will draw it like so. Now, because it can become very busy with all of these lines, what I suggest people do is make little notes. And the way we make notes is we draw what I call little toothbrushes, the toothbrush method. So I'm going to test a point away from this line. The easiest test point is 0. And I plug 0 in. Is 0 less than 4? And the answer to that is yes. Which means in reality that all the answers to this inequality are in this side of the graph. But right now I've covered the whole graph with that red. It makes it difficult to do the rest. So instead of drawing all of that, I make a note to myself with a little toothbrush that tells me the shading for the red line is on this side. These are all the solutions, these are the non-solutions. And I move to the next line. Now the next line, I'm supposed to pretend like it's y equals -3, which in this case is a solid line because of the or equal to. And I also know it's horizontal. So I have a horizontal line because it just has y that is solid, that's going to be crossing at -3. -3 is right here. So I've got a solid line there. Change this to green. And now I need to test a point. The easiest point to test is once again 0. So I plug 0 in for y. Is 0 greater than or equal to -3? The answer to that is yes. Which means in reality, all the answers to this inequality are up above. So if you think about it so far, before I've even done the third inequality, I've got all the answers that are up, and I have all the answers on this side. The section that they have in common right now is right in here. This is the area that they seem to have in common. There are answers above for this one, there are answers to the left for this one, but this little corner is all they have in common. So, rather than keeping it all too full, I'll make a little note to myself that it seems as if up, with my toothbrush method, looks like a toothbrush, that answers up are greater than -3. I move to the last problem. I know that it is solid. And I also know I can make this 1, that 1, and plus negative, and it's in standard form. And in standard form, we notice that we have a y-intercept at 4 over -1, which is -4, c over b. And I also know my slope is going to equal opposite a over b, -1 over -1, or 1 over 1. And that's all the information I need to make a graph. So I'll go down to my y-intercept, which is at -4. I know it's a solid line that goes up 1 and right 1. So I make a solid line that goes right through there. And again, I'm going to test 0, 0 because it's the easiest. And I plug in 0 plus 0 is greater than 4. And the answer to that is no. It does not work. Which means on the blue line, the shaded region is down this way. In other words, everything on this side of that blue line would be considered a solution. But I don't want to keep it a mess, so what we're looking at here is anything left of the red, anything above the green, and anything below this blue, and it sure looks like the region we'd be talking about is this little triangle right in here, which means any coordinate that is inside that triangle will work. And the reason? Because it's to the left of the red, it is above the green, and it is below the blue. In reality, the blue keeps going this way, the green keeps going this way, and the red keeps going this way. But that's the only little section that happens to satisfy all three requirements. So again, rather than keeping my whole graph confusing, I try to keep notes to myself of which direction they go, and then I look for the common shaded space. Very similar to graphing equations, you just have to look for solid or dashed lines, and then you're also looking to test a point away from your line so you know which side is a winners and losers so you can shade appropriately. Now to go the other direction, say we're given lines and we now have to write the system, it means we need two equations, we need two inequalities in this case. So a couple notes. First of all, we know it's going to either be one of those two signs because it's dashed. We also know that this is going to be either one of these signs because it's solid. Some more important pieces of information. This particular line has a y-intercept at -8. And this y-intercept is at 1, 2, 3, 4. So those are pretty important pieces of information. Also, slope. It goes up 1, 2, 3, 4, 1, 2, 3, 4. So the slope is 4 over 4, which is equal to 1. And this one goes up 1, 2, 3, 4, 1, 2, 3, 4. Or you could say it goes up 8 and right 8. But either way, it's still equal to 1. Which means in reality, this line is parallel to that line. They just have different y-intercepts. So we have to make the two graphs. So we've got one graph that's over here, which is the red solid line. And we have another line that is the green dashed. If you think about the form y equals mx plus b as your beginning start frame, it makes it quite a bit easier because you know the slope and the y-intercept. The only thing you don't want is this equal sign. You have to choose one of these signs. So I'll just pick one. I don't know if it's right, I don't know if it's wrong. And I'll say y is less than, I said the slope was 1x plus 4. This might not be the right answer. I'm going to look and see. If it is the right answer, I should be able to put 0 in and have it work. So or 0, 0. So I put 0 in for y, I put 0 in for x. Is 0 less than 1 times 0 plus 4? Well, 1 times 0 is 0, plus 4 is 4. So is 0 less than 4? Yes, it works. Had I accidentally chosen the other inequality, which I just simply picked the first one here, if I had accidentally picked greater than, this would be saying 0 is greater than 4, which is not possible. So I got lucky on my first guess. I chose the correct inequality sign. I do something very similar, but for the red line, I'm going to say y is less than or equal to, the slope was 1, x. This time the y-intercept was -8. And again, 0, 0 is supposed to work because it's a shaded region for the red line. There's no answers for the red line over here. We test out 0, 0. Is 0 less than or equal to 1 times 0 plus -8? That means it is 0 less than -8. And the answer to that is no. It does not work. Which means we have to flip the inequality sign around. Now we test out 0, 0. Is 0 greater than -8? And the answer is yes. So that is the correct answer. So when it comes to making the inequality for what you see, you need two pieces of information to begin with. You need the y-intercept and the slope, and then you need to pay attention to whether it's a dashed line or a solid line. Then you make your inequalities and you test out a coordinate you know is supposed to work and see if it actually works. If it works, you guessed correctly with your inequality. If it doesn't work, that means the inequality is wrong. You switch it and then try it, and it should work then. Alright? This one has 1, 2, 3, 4 different inequalities. Let's space this out a little bit. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7. 1, 2, and 1. Now, as far as our, that's negative 1 and negative 2. Our first one here, this is solid, and it's a solid vertical line at 1. So a solid vertical line at 1 is going to be right here. I'm going to test a point away from it, like 0. Is 0 greater than 1? The answer to that is no, which means the shading would be on this side. There's my toothbrush. The next one is also solid, and it's another vertical line, but this time at 4. So I go out 1, 2, 3, 4, and I'll change this to green. Okay, test 0, 0, or 0 out. Is 0 less than or equal to 4? The answer to that is yes, which means 0 works. It's on this side. So we shade this way. Now right now, between the first two that have been graphed, the shaded region in between is the shaded region they both share. But I have 2 more to go. So this one right here, that's a solid. And this time it's a horizontal line because it just has y. So a solid line at negative 1, which is going to be right there. And I need to test a point. So I try 0 out again. Is 0 greater than negative 1? The answer to that is yes. So I will shade up on my toothbrush. So now I'm to the right of the blue, I'm to the left of the green, and I'm above the red, which means now I'm in this region right here. Anything in here works. Not below the red anymore, above the red. And I have one more, which is going to be a diagonal line, and it's also a solid. Has a y-intercept at 1, which is right there, and it goes up 1 and right 2. Up 1, right 2. Up 1, right 2. Up 1, right 2. So now I have a solid line here. And I test 0, 0 out once again because my line doesn't go through the origin. Half of 0 doesn't exist. Is 0 less than or equal to 1? The answer is yes, it is. So it's going to shade down. So if you look at all 4 toothbrushes, it's to the left of the green, it's to the right of the blue, it's above the red, and it's below the black. That means it's going to be above the red, which is in here. It's going to be to the left of the green. It's going to be to the right of the blue. And it's going to be below the black. So that is the section that they share in common for all 4 inequalities. Any coordinate inside this region would work for all 4 inequalities. So it's a solution to the system. And that's how you graph a system of inequalities.